All right, welcome back. We're going to do the actual number 5, where now the difference is that you still have a lamina occupying the disk x squared plus y squared less than or equal to 36 in the first quadrant. Still want to find the center of mass, but now the actual problem said the density at any point is proportional to its distance from the x-axis. So let's zoom in a little bit here. Proportional to the distance from the x-axis means you have a y there. K times y. In polar coordinates, k times r sine of theta. So our mass is going to be k times r sine theta times r dr d theta. Okay? I'm going to pull the k out. R squared sine theta dr d theta. Theta goes from 0 to pi over 2, as you can see. R goes from 0 to 6. Okay, and now we're no longer, this density is not symmetric. So we no longer expect a symmetric answer. Okay. Same thing that we did on the last one. X bar includes x. So x times rho dA divided by the mass. Okay, so x in polar coordinates is r cosine theta. Density is k times r sine theta. We had that over here. And dA is r dr d theta. The mass we've already figured out. And now these k's cancel. Okay, so if I want to write this, I could write this without the k's. Let's write this. There are 1, 2, 3 r's. Cosine theta, sine theta, dr d theta, over, in the denominator, r squared sine theta dr d theta. Now, in order to integrate this, I'll give you a little hint. Cosine theta, sine theta, it's not too difficult to integrate, but I would write that as 1/2 sine of 2 theta. Okay. The other integral, the y bar, is going to be 0 to pi over 2, 0 to 6, 1, 2, 3 r's, so r cubed. Sine squared of theta, dr d theta. And in the denominator, 0 to pi over 2, 0 to 6, r squared sine theta, dr d theta. Okay, and then to integrate this numerator, I'd remember that sine squared of theta is 1 minus cosine 2 theta divided by 2. Okay, all right. I'll let you guys go forth. I will start putting 12.5 lectures up next, probably later Friday afternoon. Okay?